So I think yesterday I have given you the introduction of work. Am I right, everybody? As we started in the next chapter, work, energy, and power. So I introduced the what is the formula for work, and when we can say work is positive, and when we can say work is negative, and when the work done by the gravity and as well as work done by the normal is equals to zero. Am I right, everybody? All of you? Yes. And yesterday, before closing the question, I have taught you an important concept. So just have a glance that is what, as I told you, this is very important concept. So we all people knows that work done is equals to Fs cos theta, and the same formula we can write it as a W is equals to what, everybody? F cos theta into S.
Yes,
And the next one is what? Work done is equals to what, everybody? S cos
yes,
theta into
Karthik.
F. So we have done that. These both are not same. So there is a difference. There is a difference. So what is that? So if I have taken here, if suppose if any object is there, if it is moving in a displacement like this and having a force exerted by it is F, and the angle between them, force and displacement, is theta. So means in the sense of the component of force exerting in the direction of displacement, what will become, everybody? The component of force exerting in the direction of displacement is F cos theta, and the component of displacement in the direction of force will become what, everybody? Yes, please. It will become
Yes,
yes.
Karthik.
Again, I'm repeating. The component of force in the direction of displacement is F cos theta, and the component of displacement in the direction of force is S cos theta. Am I right, everybody? Clear? All of you what I'm saying? So this is what the concept we studied. So based upon this, now we are going to solve the most one of the very important question. So that is what? So let us take hemisphere. I think here any hemispheres is there in the shape. So let me verify. Check it, everybody. Is there any hemisphere? Shall we go with this? Yes. So we'll try for with this. So we all knows that, or else you can take like a circle. So let me take it now. So I'm taking as a hemisphere. So it is not perfect hemisphere, but let it be. I'll make it. Okay, everybody. So you draw it. Try to draw. So I'm taking a hemisphere. So hemisphere means you all people knows, but it is not correct. Okay, let me draw with the hand itself. So we all knows that hemisphere means it's a half of the spherical. So, but you all know from the center, if you go any direction, what will happen, guys? The displacement is how much? All of you. Yes, please. So let me draw. From the radius, if I go from any point, the radius is become what? All of you. Yes, please. At any direction, radius is same. Okay, guys. So just I'm imagining you draw only lower part alone. Don't draw upper part. Is it okay, Rudreshwar? What I'm saying? Clear?
Yes, sir.
Yes. So imagine that there is a like hollow sphere, hemisphere. So from the center, I will take it as some object is hanging. So just imagine that some object is hanging whose mass is m. Whose mass is how much? M. So from here to here, something we can call from the center. What is that called as? Everybody. Yes, please. That is called as what? Radius.
Radius.
Okay, not resultant. It is the radius. So that is what. Now observe very carefully. Here, this body has been taken to this position. This body has been taken to this position like a pendulum. Do you understand what I'm saying, all of you? So the body has been taken to this position. So here the body came with the help of applying force. For example, here if you notice it, here also direction of applying force is the same. And here also the direction of applied force is same. The force, direction of force is not changing. Do you understand, everybody? Direction of
Yes,
force
sir.
is not changing. Clear, everybody? So, but if you notice it, so initial position and final position, the angle between them we can assume as a what, everybody? Yes, please?
Theta.
Theta. And can you tell me from here to here also we can call, what is that called as?
Radius.
Radius. It is always equal. Am I right or wrong, everybody? Clear? All of you? Find work done by force. by force F. That is the question. Find work done by the force F. So let us see that. So let's start finding. Now remember, upper part you people should not draw. Clear everybody? All of you? So only bottom
sir.
part alone. So just for my purpose, I have drawn.
Yes, sir.
Now, so we all knows that work done formula. What is the work done, everybody? All of you respond. So work done is equals to what is the formula? All of you? Fs.
Yes, yes, yes,
Fs.
cos theta.
We have to find that work
Fs
done by
cos
this
theta.
force. Work done by the force F, we have to find it. So all of you observe very carefully. So if you notice it here, so if you notice it from here to here, so what is the displacement I want to find in circular motion? You all people know. Of course, this is the hemisphere. All of you remember hemisphere. Okay, you should not draw this part. I'm striking it. Okay, everybody. Now all of you observe very carefully. So from here to here, displacement. This is the initial position and this is the final position. If I want to find displacement, I have to draw something. Anybody can tell what do I have to draw? Displacement means shortest path. Am I right, brothers? Displacement means shortest path. This is what we used to call as displacement by the body from the initial position to final position. Am I right, guys? Everybody?
Yes, sir.
Please respond. Now, all of you observe very carefully. So this is the displacement of the body and this is the applied force. So means in the sense of the force is acting in this direction. Am I right, Rudreswar? Clear?
Yes, sir.
All of you understanding, Amma? So now all of you see here, here is the theta. Then can you tell me the components? We all knows that if here is the theta, then here what will happen? In X here, closer to the theta, something will come. Imagine like a triangle. So if I imagine
R
like
cos theta.
something, all of you observe this is what here. If here is the theta, then here what will happen, everybody? For example,
Down cos theta.
here what will happen, everyone speak? R cos theta.
Cos theta.
And opposite what will come? R sin theta.
Sin theta.
Now if you notice it here, this is the triangle and this is the another triangle. Am I right, Idresa? So here what side of a triangle. So here what will happen? This will become R cos theta.
Cos theta.
And opposite one what will happen? R sin theta. R sin theta. Is it okay, everybody? Clear? Actually, it has to come here. That is parallel shift is this only. Am I right?
Yes, sir.
Yes, that is what. So parallel shift become here. So that is what R sin theta. So now, if you observe work done by what we have to find it? All of you. Work done by the force we have to find it. So if you notice it here, force is acting in the direction of what? All of you. Component of displacement in the direction of what, everybody? Component of displacement in the direction of what? Everyone. Force. Understanding? So work done is equals to component of displacement in the direction of what, everybody? In the direction of respondra.
Force.
In the direction of force. Okay. Into force. That is what it is. So what is the component of displacement in the direction of force? Everybody check it. The component of displacement.
Yes, cos theta.
Or cos theta, sin theta. Direction of force,
Yes, sir.
direction of C, component of displacement in the direction of force. The direction of force is this one. So what is the component here present in the form of displacement? What is the displacement? Component
R sin theta.
Component of displacement in the direction of force into force. So force is equals to force. What is the component of displacement in the direction of force, everybody? In the direction of displacement, what is the component is present here? Everyone.
R sin theta.
R sin theta. So work done by the body is equals to, what is the formula? Everybody, in hemisphere, R sin theta into force. That is what it will be happening. So once again, I'm repeating, all of you be very careful. So as it is, theta is existed here. So we all knows that this will become radius. And here also it will become what, everybody? It will also become radius. Am I right? Clear, everybody?
Yes.
So then this side it will become R cos theta. And then next side it will become what? Everybody, parallel shift. Of course, here it should come R sin theta. So as we are talking here, it will become parallel shift. This also will become R sin theta. Am I right or wrong, everybody? Yes?
Sure.
All of you? Then this is only called as, what is that? Component of displacement in the direction of what? Component of displacement in direction of?
Force.
Direction of force, which is equals to r sin theta. So that's all. So component of displacement, that is what work done. This is the work done. What is this work done? That work done is equals to component of displacement in the direction of force, because direction of force is not changing. Here also direction of force in the same direction. Here also direction of force in the same direction. So direction of force is not changing. So the component of displacement in the direction of force is how much, guys? R sin theta. Do you understand, everybody? Because displacement is like this direction. Am I right, Rudreswa? All of you? Yes. If the suppose displacement is like this direction downwards, then what is the component of displacement in the direction of force? Everybody. R
Cos theta.
cos theta. Now displacement is like this direction. So who is the present? Who is present the component of displacement in the direction of force? Everybody check it here. This is the displacement and this is the applied force. So applied force. So who is present? The component of displacement present in the direction of force, which is equals to how much it is, everybody? R sin
Theta.
Okay, so that is what? So sin theta into applied force. That's all, which is equals to work done by the body. Clear, Pradosh? All of you? Yes. So
Yes, sir.
this is what it is. So in hemisphere case, what is the formula? W is equals to work done by the body is equals to R sin theta into force applied. That is what you have to remember. Okay. So please mark it. So this is one of the. Now, next question is pulley questions. The questions which we studied already. So now here onwards, we are going to make in the form of work, energy, and as well as power. Now, as we are discussing about the work. Now I am drawing a pulley now. Everybody tell me, it is a fixed pulley or mobile pulley? Pulley. It is a fixed pulley or mobile pulley?
Fixed.
Pulley. Yes. Fixed pulley. So let me take one side. So there is a object 1 kg mass. How much mass of the object, everybody? 1 kg. And another side there is a mass which we used to say 2 kg. How many kg, everyone? 1 kg and 2 kg. Okay, everybody. So now question is, all of you have to redraw the diagram. I won't draw again. So find work done by gravitational force. All of you understanding, everybody? Find work done by gravitational force on each mass, and as well as tension force, tension present. Why tension? Strings are present here. That is why find and tension force on each mass when 2 kg mass down by 3 meters. Do you all understand, everybody? So please read the question one. So what is the two things we have to find here? What is that? Find work done by gravitational force on each mass and as well as tension force on each mass when the 2 kg mass goes down how many meters, guys? Yes, please. 2 kg mass will go how many meters?
3 meter.
3 meters.
Now you tell me, if 2 kg mass goes 3 meters downwards means, then 1 kg mass will go how many meters upwards?
3 meters.
It will go upwards.
3 meter.
Am I right or wrong? Everybody? Clear?
Yes, sir.
That is what. Now, as this mass is coming downwards, redraw the diagram and make. What is the weight of the body acting downwards? Fastly. Weight of the body downwards. What is that? 2g. Okay, clear, everybody? And tension is acting upward direction. So now acceleration downwards or upwards? Acceleration downwards or upwards? And here
Downwards.
and tension is acting same string, same tension. And here acceleration is what? Upwards or downwards? Fastly. Upwards. Clear?
Upward.
Now, work done. Work done by gravity. Let us find first. So work done by gravity on 1 kg mass, which is equals to, check it, everybody. Acceleration is also same direction, all of you. And you can see all of you. Check it, everybody. And displacement, all of verified. Work done on 1 kg is equals to. Can you tell me what is the formula? All of you. Check it, everyone. So gravity is acting downward direction and displacement of the body is upward direction. So work done is positive or negative? Both are opposite direction. So 180, cos 180 is equals to how much?
Minus, sir.
minus. So if
Negative.
you all notice it here, so body is displacing upward direction, gravitational force is acting downward direction. So what will happen, guys? Work done is negative or positive? All of you?
Negative.
Negative. That is
Negative.
what? Fs cos 180. So Fs cos 180 means minus Fs. Am I right? Everybody, cos 180 is equal to how much?
Yes, sir.
That is. So what is the
Minus
answer? Minus. What is the force exerting here? How much it is?
1G.
1G.
Understand? Into displacement, how much?
3.
Up. If this body
3
comes
meters.
down 3 meters, see, second 2 kg mass alone question is mentioning. If the 2 kg mass comes 3 meters down means, then definitely 1 kg mass will go how many meters up? 3 meters.
3.
Understand?
3 meters.
Which is equals to 3. So which is equals to G value 10. So 1 into 10 into 3, which is equals to how many joules, guys? Work done by the A.
Minus 30
joules.
joules.
Mass is negative work done, that is minus 30 joules. Then work done by gravitational force on 2 kg. So now you tell me, gravity is also acting same direction, body is also moving in the same direction. So then work done is positive or negative?
Plus Fs.
Yes, plus. Both are angle is 0. So Fs is equals to 2g into 3 meters, which is equals to g value is 10 into 3, which is equals to how much, Ra? 20 into
60.
3, which is equals to how many newtons? Oh, sorry, how many
16
newtons?
newtons.
Newtons.
16 joules, sir.
60 joules.
16 joules.
And work done. Work done means joules. Clear, everyone? All of you? Yes?
Yes, sir.
Yeah. So
Yes,
now we
sir.
found it everything. So work done by the gravity is completed. Then what we have to find next one? They asked her to find what? Work done by tension on 1
Tension.
kg and same way work done by tension on 2 kg. Now, if you want to find the work done due to the tension, so immediately you need to know some other thing. If you want to calculate the tension means force. Tension means force, which is equals to what? Mass into all of you, acceleration. Clear?
Acceleration.
So you need to know acceleration. If you want to calculate the force exerted by tension, first of all, you need to calculate what? Everybody. You need to calculate
Acceleration.
acceleration. So let us see how much it is. Okay. So all of you, everybody, we can find the tension. So how to find it? Everyone check it. First, free body diagram for 1 kg draw. Everybody, 1 kg tension is acting. FBDs draw. Same. We are very familiar in this. Tension is acting upward direction. 1G is acting downward direction. But displacement of the body is upward or downward? Upward. Am I right?
Upward.
So that it will turns into what? This is positive and this is negative. So that what will happen? T minus G is equals to A or 1A. Am I right, everybody? Clear? Then
Yes, sir.
Yes, sir.
FBD. You should speak FBD for 2 kg mass. What is that? This is 2 kg. So 2 kg tension is acting upward, but downwards is 2G and acceleration is downwards or upwards? Downwards. Then this is positive and this is what? Everybody should speak negative. So it will turns into 2G minus T is equals to 2A. Am I right, everybody?
Yes,
All
sir.
of you?
Yes,
Then what
sir.
will happen? TT will get cancelled. 2G minus 2. Add these two equations. What will happen? 2G minus G, which is equals to how much? G. G is
G
equals
equal to.
to A. Then A is equals to
G
what,
is-
everybody? A is equals to what? Yes, please. G
G
by
by
3.
G by 3.
A is equals to G by 3. Is it okay, guys? If you are not familiar with this, you can write generally 2G minus T is equals to 2A and T minus G is equals to 1A. So that you can easily cancel. You can get G is equals to 3A. Then A is equals to G by 3. Is it okay, guys? Everybody? Whatever you are convenient, you can solve. Okay, guys? Yes?
Sir.
Then you can substitute in the
Yes,
T
sir.
value for finding. Any one equation, you can find the acceleration. So T minus 1G, which is equals to 1A. Now, I'll substitute T minus G is equals to acceleration means what, everybody? Acceleration means G by 3. So tension is equals to both strings same tension. So G by 3 plus G, which is equals to LCM is 3 here, G plus 3G.
4G by
How
G.
much, guys?
4G by 3.
What is tension, everybody? Tension is equals to 4G by 3.
4G by 3.
If you want value, you can take G value is equals to how much? You can take value, G value is
10.
equals to 10 and you can find this one. Is it okay, everybody? All of you? Yes? This is also one of the most important question. Please, all of you, if you understand or not, let me know. If you understand, that's fine. Aswita, understand? Morning, you have to wake up, Aswita. I want to see the complete progress by you. I'm particularly asking if you are already capable, you have to work. I'm saying no more cheatings and all. Everybody understand this question? Anyone having doubt, please kindly let me know. Okay, everybody?
Sir, 2 kg more, sir.
Yeah, 2 kg is not required. Both same tension, correct, Rudresh sir? Same string, same tension.
Sir, direction opposite we should to minus.
Yes, opposite direction. Then why are you worrying? Tension is only correct. They are asking the force exerted by tension. What the same string, same tension. If you calculate this tia, that tia, both are same only, correct?
Okay, sir.
Hey, if you
We
want
need
to
not to put minus, sir.
It's not tension both direction. It is acting tension both cases. It is acting same direction, correct? Here, if you want put, of course, this here you are saying that so acceleration is equals to minus g by 3. You are saying that. Am I right?
Yes, sir.
Both the cases acceleration is same. This plus or minus will indicates what direction. What is the? You understand?
Okay, sir.
Okay. So that's what tension. So tension is equals to 4g by 3. Now, this is general approach. All the people can see. But you are a JEE aspirant or NEET aspirant. So do we follow this much big method to calculate the tension exerted by this? Writing the free body diagrams, writing the equations, cancelling out, substituting this all. So this all we people cannot follow in for competitive exams. So there is a shortcut formula for calculating tension. Clear, everybody? So what is the formula? Remember in mind, like these cases, if they'll ask you to calculate the tension, all of you remember, the formula is 2 into m1, m2 divided by m1 plus m2 into g. That's all. You'll get the answer. So if you want to substitute it, 2 into, what is the mass of the body? 1 into, mass of the body is 2 divided by, mass of the body is 1,
3.
1 plus 3, 1 plus 2 into g. Okay, everybody. So do it. 2 2 is how much? 4.
4g by 3.
3, which is
4g
divided
by 3.
or the answer. That is a shortcut formula. Please remember. Clear, everybody? All of you?
Yes, sir.
Right. So please finish it. Any doubt? You can ask. Hope everybody understand, Mr. Monesh. For those. Okay. So now, how much it is? We have to calculate it. We found the tension 4 by 3 G, but we have to calculate work done by the tension on 1 kg. So how much it is? Let us calculate it. So how to find it? Work done by tension. All of you check it. Work done by tension. Tension and acceleration both are same direction. So work done is positive or negative? Opposite to first case. Work done is positive or negative? Everybody. See, work done by gravity is opposite. Now tension and acceleration both are same direction. Body is moving in the same direction. Work done is also same direction. So yes, please respond. For tension is and displacement is same direction. So work done by tension on 1 kg. Positive or negative? Work done by gravity is negative for the 1 kg body because gravity is acting downwards. Displacement is upwards. Work done by gravity for second body is positive because gravity is also downwards, displacement also downwards. Now the question is, work done by tension on 1 kg is positive or negative?
Positive, sir.
Positive.
Why? Tension is also upward and displacement is also upward. But work done by tension on 2 kg body, negative or positive?
Negative.
Yes?
Negative.
Negative. So that is what. Understand, for those that value you found it, but you have to find the value. So I'll find it now. Work done by tension on 1 kg. So which is equals to how much? Work done is positive because same direction. Please mention it. Tension is also same, displacement also same. So positive work done. So which is equals to F. I got it. That is what? Tension is equals to F. Am I right or wrong? Everybody?
Yes, sir.
Yes, that is what. So 4g by 3 into what is that? Yeah, next one. Yes, displacement is how much? Upward direction. How much ra?
Three.
Downward 3 means upward also 3. So
3 meters.
cancel. So 4 into 10, which is equals to how many joules? Everybody?
40
Plus
joules.
40 joules. Plus 40 joules. Next, second body displacement is down, tension is up. So that work done by tension on 2 kg mass, which is equals to negative work done or positive work done? Negative work done. So minus 4
40.
into displacement 3 will get cancelled.
Minus
Minus
40.
40 joules. So have you all understand, everybody? All of you?
Yes, sir.
Yeah. Then now net force. What is the net force done by the tension force? Anybody can tell? Net force. Net tension. Understanding? Tension done by the both bodies. Net tension force is equals to how much it is? Anybody can tell? Net tension force, upward upward 40,
Sir, 40 minus
downward
of
minus 40. So what will happen? 40 minus
sir,
of
40 minus of minus 40.
yes. No,
0.
40 plus minus 40. Understand, Rudreswa? Both adding. So that it will turns into 40 minus 40, which is equals to how much? Net
Zero.
force.
0, sir.
0. Net tension force, which is equals to 0. Is it okay, everybody?
Yes,
Yes,
sir.
sir.
So that is what you have to remember. Anybody having doubt in this, please let me know. Clear, everybody?
Yes.
Yeah. Clear, everyone? Yes?
Yes, sir.
That's what. Now, so there is, of course, we have some time, so we'll do it now. So all of you observe very carefully. So if I take now force and displacement, all of you remember that if force and displacement, the angle between them, okay, the force versus displacement, angle between them is less than 90. So it is acute angle. What angle it is? All of you? Acute angle. So cos theta is always positive. Cos theta is always what? Positive. So that work done is also what? Everybody. Work done is also
Positive.
Positive.
If angle between the force and displacement is greater than, theta is greater than 90. Clear, everybody? Then cos theta is equals to what? Everybody.
Negative.
Because if it is what angle? Obtuse angle.
Close angle.
Obtuse angle. So if it is obtuse angle, so then what will happen? Work done is what, everybody? Work done is what? Negative. So more than 90 means the force is acting in this direction and the displacement will be in this direction, like this, for example. So it is greater than 90. Am I right or wrong? Theta is greater than 90. So in these cases, work done is equals to what, everybody? Work done is equals to negative. Okay. If theta is equals to 90, then work done is equals to what, everyone? 0.